Hello friends, welcome to Mathematics Made Easy tutorial. This is MPage 101 and we are looking at problems on integration by parts. Problems on integration by parts. Of course, recall that integral u dv equal to uv minus integral v du. Of course, we want to call it equation 1. And this is the key principle behind integration by parts. Integral u dv equal to uv minus integral v du. Of course, it's coming from product rule from differentiation. Alright, let's look at the typical problem, how we can apply this principle to solve it. Example 1, evaluate integral x exponential 3x dx. Evaluate integral x exponential 3x dx. You observe that there is going to be always products. You have x on its own a function and exponential 3x dx on its own a function. Now, look at the key principle. For the fact that we have two functions, one of them going to be our u and the other one going to be our dv. So coming back to the problem we are looking at now, we said let x u, the first x being the first part of the function, we said let u equal to x. And of course, if u equal to x, differentiating as du over dx, du over dx equal to 1. Of course, cross multiplying, we have du equal to dx. And again, the second part, if x from our integral is u, then exponential x dx is going to be our dv. So dv equal to exponential 3x dx, which implies integrating our v equal to 1 over 3 exponential 3x. How do we got that result? We wonder how. Let's go to our rough corner. If dv, that's where we are coming from, equal to exponential 3x dx, how do we go about it? It's okay. Let u equal to 3x. We are saying that we can represent u as 3x. So 3x will be taken and replaced by u. And again, differentiating that function, du over dx equal to 3. And of course, dx will be du over 3. That is cross multiplying. We're going to have du equal to 3 dx and dividing both sides by 3 so that your dx equal to du over 3. Now, let's see how we can replace u as 3x and then dx as du over 3 in the integral we have. So we are going to have dv, which is still there, equal to, where we have 3x now, will be replaced by u. So we are going to have, instead of exponential 3x, we will be having exponential u. Then instead of having dx, because now our dx we said is du over 3. So in place of dx, we are going to have du over 3. Du over 3. Now integrating both sides, integral of dv equal to, of course, over 3. 1 over 3 is constant. We bring it out, integral exponential u du. And that is integral dv is equal to v. And of course, integral exponential u, exponential x, exponential t, the same thing, going to exponential u. And of course, u is 3x, my result is 1 over 3 exponential 3x plus c, where c refers to constant of integration. So, if you have dv equal to exponential 3x dx, the result, the answer you're going to have after integration equal to v equal to 1 over 3 exponential 3x plus c. So that's how we got this result. Our v, for the fact that dv equal to exponential 3x dx implies our v equal to 1 over 3 exponential 3x. Now, Now applying question 1. What's in question 1? Our main principle, which is integral u dv equal to uv minus integral v du. That is our question 1. Applying that principle, question 1 in equation 2. In equation 2. Question 2, what is it saying? That is the main problem we intend to solve. Integral x exponential 3 dx, which is equation 2. Applying question 1 in equation 2 using equation 3. Question 3, how to do it? Our 4 parameters. 1, u equal to x. 2, du equal